Commercial parking structures require mechanical ventilation under certain conditions. Vehicles with internal combustion engines produce toxic exhaust gases that can accumulate inside enclosed garages. These include carbon monoxide, nitrogen oxides, gasoline vapors, and diesel emissions. In this video, we'll explain when garage ventilation is required by code, how the required airflow is calculated, typical garage ventilation layouts, and the control strategies used to keep occupants safe. Carbon monoxide is a colorless, odorless gas that is highly toxic to both humans and animals. The effectiveness of a garage exhaust system depends on several factors, including the amount and location of the makeup air, the placement and capacity of the exhaust fans, and the location of the exhaust inlet points. There are several acceptable design approaches, but they all share the same objective: maintaining safe carbon monoxide levels throughout the garage. Code requirements. According to ASHRAE Standard 62.1/2025, the recommended garage exhaust rate is 0.75 CFM per square foot, or 3.8 liters per second per square meter. Always verify the requirements adopted by your local jurisdiction, as ventilation rates have changed over the years. In our example garage, the floor area is 61,200 square feet, or 5,686 square meters. Multiplying 61,200 square feet by 0.75 CFM per square foot results in a required exhaust airflow of 45,900 CFM, or approximately 78,000 cubic meters per hour. Using a typical garage floor-to-floor height, this corresponds to roughly 4 to 5 air changes per hour. Locating the sensors. Large parking garages are often divided into multiple ventilation zones, each served by its own makeup air and exhaust fans. When carbon monoxide rises within a particular zone, only the fan serving that zone needs to increase speed. Carbon monoxide sensors are typically installed within the breathing zone, approximately 5 feet, 1.5 meters above the garage floor. Depending on the manufacturer and the openness of the garage, each sensor typically monitors between 5,000 and 10,000 square feet, 465 to 929 square meters of floor area. In this example, each shaded circle represents approximately a 45-foot, 13.7 meter radius, covering about 6,360 square feet, 590 square meters. Based on the garage size and sensor coverage, this layout requires 8 sensors to provide complete coverage while maintaining a reasonable safety factor. Controls. Many building codes permit demand-controlled ventilation, allowing the exhaust system to operate only when elevated carbon monoxide levels are detected. Throughout the garage, CO sensors continuously monitor air quality and transmit their readings back to the main garage controller. Most systems use 24-volt DC power along with an RS-485 communication network, allowing multiple sensors to be daisy-chained together. One manufacturer's controller can monitor approximately 100 sensors. The controller is also connected to the exhaust fan VFDs, makeup air fan VFDs, alarm horn, flashing strobe light, and often the building automation system through an Ethernet connection. This allows the controller to continuously monitor the garage while automatically adjusting ventilation based on actual carbon monoxide levels. Measuring and controlling CO levels. Carbon monoxide concentration is measured in parts per million, commonly referred to as ppm. For example, 200 ppm means there are 200 molecules of carbon monoxide in every 1 million molecules of air. Prolonged exposure to this concentration can cause headaches, dizziness, nausea, and fatigue. The carbon monoxide thresholds used to control garage ventilation vary depending on the mechanical code adopted by the local jurisdiction. One code may require the exhaust fans to start when carbon monoxide reaches 25 ppm, while another requires the system to maintain an average concentration below 50 ppm over an 8-hour period. These limits are automatically maintained by the garage ventilation control system. In a typical control sequence, sensors throughout the garage continuously report carbon monoxide levels to the garage controller. As CO concentrations increase, the controller commands the variable frequency drives to increase the speed of both the exhaust and makeup air fans. For example, when CO reaches 25 ppm, the fans may operate at low speed. If any sensor detects 50 ppm, the controller increases the fans to full speed while sending a low-level alarm to the building management system. If carbon monoxide reaches 100 ppm, the controller activates a high-level alarm, sends a signal to the building management system, and energizes both the flashing strobe light and audible horn to warn garage occupants of potentially unsafe conditions. Garage design layout options. Here are several common ventilation strategies used in commercial parking garages. The actual design varies depending on the building configuration, local code requirements, and whether the garage is above or below grade. One-level parking, non-ducted system. In this arrangement, the vehicle entrance often serves as the primary makeup air opening. Exhaust fans located at the opposite end of the garage draw fresh air across the entire parking level. Additional makeup air louvers may be installed to improve airflow and eliminate stagnant or dead air zones. The exhaust fans discharge the contaminated air to an approved outdoor location. Multi-level parking, non-ducted system. For multi-level garages, makeup air fans at ground level may supply a vertical shaft serving each parking level. Motorized dampers and louvers regulate airflow into each floor. If the shaft is fire-rated, fire and smoke dampers may also be required. This video focuses on normal ventilation. Many jurisdictions also require dedicated smoke control systems for fire events, along with smoke purge operation after the fire has been extinguished. Multi-level parking, ducted system. Another common approach uses ductwork to collect exhaust air from multiple pickup points located throughout the garage. This arrangement allows the main exhaust riser to be located in one corner of the building, which is often necessary when a high-rise structure occupies the space above the garage. There are many variations of both ducted and non-ducted garage ventilation systems, depending on the building layout and project requirements. Summary. Garage exhaust systems protect occupants by preventing the buildup of dangerous carbon monoxide inside enclosed parking structures. They accomplish this by continuously monitoring carbon monoxide levels and introducing outdoor makeup air while exhausting contaminated air to the outside. Whether the system is ducted or non-ducted, the objective is the same: maintaining safe air quality for everyone using the garage. If you found this video helpful, be sure to check out our HVAC and plumbing estimating spreadsheets to streamline your construction bidding process. Check out our HVAC, electrical, and plumbing construction forms to help you run your business, and explore our online courses for in-depth training.